So part B of standard 13 says, given the integral 0 to 1 of e to the root x over root x dx, that's an improper integral. And so we have to explain why and determine the the value of the integral, or show that it diverges. And so you can sort of just tell by eyeballing it that this integral is improper, because an improper integral is one that has one of its bounds infinity or negative infinity, or its integrand function has a vertical asymptote somewhere in the bounds of integration, which in this case are 0 and 1. And so this improper integral is because of the latter reason, because when the integrand function e to the root x over root x, when you plug 0 in for x, that function value will be e to the 0, which is 1 over 0. And 1 over 0 is undefined. So the graph of e to the root x over root x has a vertical asymptote at x equals 0. So the area under that graph is a little harder to find, which is what the integral gives. And so therefore we have to solve this integral with a limit. And I did solve the integral with a limit and used u substitution, because e to the root x over root x we have no antiderivative rules for. So I made u equal root x, and du dx equals 1/2 x to the negative 1/2 by the power rule, which when simplified you get dx equals du 2u. And then u of 1 is 1, and u of k equals root k, and those are our new bounds of integration. And so the integral I solved was limit as k goes to 0 of root k to 1, the integral from root k to 1 of e to the u over u times 2u du, subbed in for dx. And so simplified to this, limit as k goes to 0 of the integral of t to eu du from root k to 1. And so the antiderivative of 2e to the u is 2e to the u. And so we want the limit as k goes to 0 of that from root k to 1. And so when we plug 0 in for root k here, to solve that, we get 2e to the 1 minus 2e to the root 0, which is 2e minus 2. And that's our answer.